All right, everyone. Happy Tuesday. Not exactly what we had planned, but that's fine. We're going to make it work. Um, I am doing the entire lesson together. So this video is definitely going to be long, but again, you're not doing school today, so enjoy it. It is a key concept that we're going over here, so it is a critical one that you need to pay attention to. It should be pretty straightforward, but if you're not paying attention, it might be an issue. Okay, so we are going to be doing lesson 822, as you see up here, 822, and we're going to basically do all the problems here together. You need paper and a calculator. Your homework is 69 through 75, and you will need some graph paper for that, okay? Even though a lot of the work we're doing today is doing graphing, we're not going to actually do it on graph paper for the lesson, okay? So here we go. We did go over the homework already, so that should be fine. Straight to 822. How are quadratic rules and graphs connected? And it's called the zero product property. Zero product property. You already know a lot about quadratic functions, and you have made several connections between the different representations on the quadratic web. Today, you're going to develop a method to sketch a parabola. Now, this is a key thing. Sketch. A sketch is a simple, quick drawing, but it should be fairly accurate, okay? From its equation, you're going to sketch a parabola from its equation without a table. Without a table. That's a big thing, because up to this point, we've been doing kind of make a table, and then after you make a table, you got to plot it. Remember, like with the water balloon thing? So we're going to go straight from an equation to a sketch of a parabola. Got it? Here we go. 864. What do you need to sketch a parabola? How many points do you need in order to sketch a parabola? 1, 10, 50? Think about this as you answer the questions below. Note, a sketch does not need to be exact. The parabola merely needs to be reasonably placed with important points clearly labeled. Now, that's one of the big things right now. When we do make a sketch, which is going to be quite often now with parabolas, it doesn't need to be perfect, but I do need you to identify key points, and we'll find out what those key points are. First of all, A, can you sketch a parabola if you only know its y-intercepts? For example, if the y-intercept of a parabola is at 0, negative 15, can you sketch its graph? Why or why not? I want you to think about it for a second. Well, what do you think? Can you? If I've got my graph and the y-intercept is 0, negative 15, and I go 0, comma, negative 15, what would the parabola be? Well, it would be like this, right? But wait a minute. Could it be like that? What if it's like this? Or what if it's woo? Or what if I go like this or like this? Would that work? All those would work. So is the y-intercept enough? No, it is not enough. The y-intercept alone is not enough. Now, you know what? Go ahead and write that down. But from now on, we're going to do a lot of just since it is a video not in class, we're going to kind of skip a lot of the explaining like writing down the explanation as long as you understand it, okay? What about the two x-intercepts? Ooh, x-intercepts of a parabola. If you only know where the x-intercepts are, can you draw the parabola? For example, if the x-intercepts are at negative 3, 0, which would be somewhere around here, and 5, 0, okay, so it would be somewhere around here. Would that be enough to sketch a parabola? Well, that would be better. Well, would it? Because it could go like that. Go like that. It could go, whoa, that's horrible. But you know what I mean. Is it enough? No, it is not. So that's not enough either. Ooh, how about, can you sketch a parabola with only its x-intercepts and y-intercept? To test this idea, right now I do want you to try this. I want you to try to sketch a parabola, and please write this equation, y equals x squared minus 2x minus 15. If its roots are at negative 3, 0, write that down. Roots, by the way, you're like, what are roots? Roots are, well, and that's a weird thing. I don't know why this book does this, but it does that. Roots are another word for x-intercepts, okay? So with roots at negative 3, 0 and 5, 0, and the y-intercept is 0, negative 15. So please pause the video and make me a sketch of that parabola. Got it? Go. Okay, hopefully you're done, and let's see what you got. So again, a sketch doesn't even require numbers. It's just going to be that right there. I know my x-intercept is at negative 3, 5, or negative 3, 0, and then 5, 0. And then, ooh, the y-intercept is 0, negative 15. 0, negative 15. So somewhere around there. Now, once you see that, now can I get a pretty clear view of how the parabola would go? I should be able to go something like this. Ooh, okay. So I do need you to write this down though. -3, 0, 5, 0. You must always, always, always identify the key points. 0, -15. Wow, that's a 5. That will work. That is pretty good. Now, is it perfect? No, it's not perfect, but that's okay. It's a sketch. Now, you do notice right here, the vertex is a little lower, right? And that kind of connects with this next question here, which is where's the line of symmetry? Where is the line of symmetry, and why did I put it there? Because this is 3 away from the y-axis, and this is 5 away from the y-axis. It wouldn't be on there. It would be in between them, wouldn't it? So it'd probably be like 4 and 4. The y-intercept should be, or the vertex, I'm sorry, in the line of symmetry should be at x equals 1. Because it's the middle. It's 4 points away this way, and it's 4 points away this way, or 4 squares away. Got it? Does that make sense? Cool. What is the coordinates of the vertex? I don't know yet, and that's okay. If I just have those 3 points, I can get a pretty good sketch of what the parabola should look like. Does that make sense to everybody? I hope it does, okay? Problem 865. In problem 864, you learn that if you can find the intercepts of a parabola from a rule, you can sketch a graph without a table. What is the rule about the value of y for all x-intercepts? Or what is true? So everyone, what is true for the value of y at the x-intercepts? Well, let's look back at it. At the x-intercepts here, and here the value of y is 0. Cool? What is true about the value of the x for all y-intercepts? Well, you can kind of figure that one out, right? X, all y-intercepts, so is 0 as well, okay? So, and it says describe the value here. So all the values are 0. Right? All the values are 0 at the x-intercept and y-intercept for the extras, okay? Now, let's apply that here. If x equals 0 at the y-intercepts, please find the y-intercept and please write 865b and write this equation down. Y equals 2x squared plus 5x minus 12. Write that down. And please find me the y-intercept. Got it? When you're done, unpause it. If you are stuck, then just go ahead and keep watching, okay? All right, here we go. So if we know that the y-intercept is where x equals 0, and I've got this equation, all I do is I plug in 0 for all my x's. Now, at this point, you should notice 0 squared is 0 times 2 is 0, so that's a 0, and 5 times 0 is that's a 0, so my y-intercept is -12. Oh, the y is -12 when x equals 0. So the y-intercept is 0, -12. By the way, in all equations, when I plug in 0 here and 0 here, won't they just eliminate? So kind of that gives us an idea of something that tells us something on the equation here, on the standard form, that might help us, okay? That is my y-intercept. Now, since the x-intercept occurs when y equals 0, oh, this is a little tougher. And here's the key thing right here, okay, ready? Write the equation that you would need to solve. Now, just write the equation that you need to solve in order to find the x-intercepts of the graph, y equals 2x squared plus 5x minus 12. Okay, go for it, okay? Well, actually, let's go ahead and do that together here, okay, ready? So just y equals 0, so 0 equals 2x squared plus 5x minus 12, right? Does that make sense? So on the previous one, I replaced the x's with zeros. Here I'm replacing the y's with the zeros. All right, and here's where it defines it. The roots or zeros, so that's why it's called roots. I'm not quite sure, but that's just the name of it, okay? So the roots or zeros of a quadratic expression are the values of x that make the value of the quadratic equation 0. So the roots are the values for x that make this equation equal 0. An x-intercept of a quadratic function is a root. Okay, so the x-intercept is the root because it makes the value of y be 0. At this point, can you solve 2x squared plus 5x minus 12 equals 0 for x? Maybe. Well, actually, yeah, but we're going to walk you through it here. Ready? So I guess in this sense, no, not quite yet. That's what we're going to learn right now. Okay, so here it is, problem 866, the zero product property. And by the way, if you need a break from me, if you're like, oh, Mr. Ramirez, I'm so sick of your voice already, just pause the video and walk around the room a little bit and then come right back, okay? So you can take a break whenever you need to here. But here is the key concept, okay? 866 is zero product property. The equation you wrote in part C in problem 865 is called a quadratic equation. To solve it, you need to examine what you know about zero. Study the special properties of zero below. Okay, now this is going to look really, really dumb, sound really, really dumb, but stick with me here. It's really important. Nathan, Sophia, and Gaston are playing a game where Nathan and Sophia each think of a number and then give Gaston a clue about their numbers. Using the clue, Gaston must tell them everything he knows about their numbers. So A, Nathan and Sophia's first clue for Gaston is that when they multiply their numbers together, the result is 0. What conclusions can Gaston make? Well, if their product, when you multiply it, their result is 0, what can you make? What conclusion can you make? At least one of those numbers is 0, right? At least one of them has to be 0. Could they both be zeros? Yes, but at least one of them has to be 0 because 0 times anything is 0. Disappointed that Gaston came so close to figuring out their numbers, Nathan and Sophia invite Nadia to make things harder. Nathan, Sophia, and Nadia all think of secret numbers. This time, Gaston is told that with their 3 secret numbers multiplied together, the answer is 0. Woo! Very challenging people here, aren't they? What can Gaston conclude this time? Well, he should be able to conclude that one of the numbers is still 0, because no matter how many numbers you have, if one of them is 0, the product will always be 0. In fact, one of them has to be 0, okay? Because there's no other way to get 0 unless one of those numbers, at least one of those numbers is 0. Question C, does it matter how many numbers are multiplied? I guess I just gave that away, didn't I? If the product is 0, what do you know about one of the numbers? This property is called the zero product property. Okay, and it says with the class, write a description of the property and learning log. No, we're not going to do that. It's just, everyone, if you multiply numbers and the product, which is the answer to it, is 0, at least one of those numbers must be 0. Okay, so there is the problem, and you're like, that was really, really stupid, Mr. Ramirez. We know that. I know, that's fine, but you need to know that in order to answer this question. Okay, problem 867. Let's investigate how you can use a zero product property to help you solve the quadratic equation 2x squared plus 5x minus 12 equals 0 from part D in problem 865. So please examine the quadratic equation. In fact, please write it down again. 867, write down 2x squared plus 5x minus 12 equals 0. Is there a product that equals 0? If not, how can you rewrite the equation, quadratic expression, as a product? In other words, is this an area as a product? No? Then we got to get there, okay? So please pause the video and get there. Do go ahead and do that. Change it to a product. And then when you're done, unpause it and you can watch me do it. Or if you think you can beat me, you can just go ahead and do it right now, okay? So go. All right, so I need two numbers that multiply to get me 24, that add to get me 5. Now, since one of those numbers, since this product is negative, that means one of those numbers has to be positive, one of those numbers has to be negative, okay? And so I've got to do 24, and I've got to think of numbers that get me that. Oh, 8 and 3. So if I've got 8x and negative 3x, 8 times negative 3 is 24, and 8 plus 3 is 5x, so 8x. Negative 3x, and I get x and 4, and 2x and negative 3. Is that right? Cool, good. Okay, so here we go. Area as a product, x minus 4, x plus 4 times 2x minus 3 equals 0. That's what I'm aiming for. That's what I want to get to. Did you get that? Okay. Did you beat me? Did you actually get there before I did? I hope so. Congratulations if you did. Okay. All right. So now, let's go ahead and take it to the next step then. Okay. And the next step says, now that the equation is written as a product of factors equaling 0, you can use the zero product property to solve it. Since you know that one of the factors must be 0, you can set up two simpler equations to help you solve for 0. Use one factor at a time to determine what x value makes it equal to 0. So what I'm looking for you to do, and here's how I want you to have it. Okay, we've got 2x minus 3 times x plus 4 equals 0. Since this is a product, since it's this number times this number equals 0, then what the zero product property tells me is that at least one of those numbers has to be 0. So if one of these numbers is 0, if this was 0, this times this would give me 0 and vice versa. So at this point, once I've got this written down, I'm going to split it up and say, hey, 2x minus 3 could equal 0, and x plus 4 could also equal 0. Now, the value of 1 is not going to make them both 0. It just needs to make one of them 0. And then I solve this. So I do plus 3, plus 3. So 2x equals 3, divide by 2. So one is x equals 3 halves. And over here, well, minus 4, minus 4. So x equals negative 4. So that tells me the values that make the equation 0. What does that tell me? Okay. Well, here we go. Got those? Oh. All right. I must have cut off the pictures here. There were some actual questions here, C and D. And question C says, what do these solutions represent? What can they tell you? They tell you the x-intercepts. In other words, the two x-intercepts, write this down, are 3 halves, 0, and negative 4, 0. Those are my two x-intercepts or roots, okay? So now that you know that you've got that, now that you know the roots or zeros of 2x squared plus 5x minus 12, please use the x-intercepts of the graph and graph the parabola of 2x squared plus 5x minus 12 and sketch a graph of the parabola. So here are the x-intercepts. Do you remember earlier on we just did the y-intercept? Remember what the y-intercept was? We said the y-intercept right here was 0, negative 12. Let's make a sketch. Now, I don't think I've got an actual place to put it, so I'm going to have to add a page here. Okay. Add a page. And by now, you hopefully are done. Sketch. Negative, or 3 halves x. 3 halves x would be somewhere around here. Okay. Negative 4, 0 would be over here. 0, negative 12 would be about here. Okay. Now, I plot my point. All right, do my line. As you notice, this is farther away. This point is farther away from the axis or the y-axis than the other one. So therefore, my graph should hit this and go a little bit lower down and then make its way back up. Okay. At this point, I don't need to find the exact vertex or the exact line of symmetry as long as it's fairly close, even though I could. Negative 4, 0, and then 3 halves, 0, and then 0, negative 12. And this would be the equation or the sketch of my graph. Cool. All right, that's the process. And so, see, there it is. It was just skipping. It was skipping double again, as always. All right, let's practice it now. 864. Can you make a sketch of a parabola from two x-intercepts and the vertex? Ooh, how about the vertex this time? A, find the x-intercepts of the parabola, 0 or y equals. It's a different equation. So, right, 868, write this equation down now, please. Then find the vertex and make a sketch. Now, there's a lot to this here. Ready? So let's try it. So I want you to please go ahead and on your own, find the roots. Okay, find the roots. So You can go ahead and do it. I'm just going to do it up here on the screen as well. Okay. Now, again, they have to be negative. One's negative and what's positive. The bottom value has to be negative, so that means negative 4x has to be bigger. So I've got negative 4x and 2x. So x minus 4 and x plus 2, right? Cool. So there are my roots. So, well, there is my equation. X minus 4 times x plus 2 equals 0. At this point, I split it up and say x minus 4 could equal 0, and x plus 2 could equal 0. So I do plus 4 and plus 4. So x equals 4, minus 2, x equals negative 2. So my two roots are 4 and negative 2. So I could already go ahead and make my sketch, or at least start my sketch and say, hey, one root is going to be at 4, 0, and one is going to be at negative 2, 0. Now, it says, how do I find my vertex? Find the vertex. Well, the vertex is the midpoint, right? It's going to be in the middle of these two lines. So no matter where it's at, it could go this way or it could go this way. Now, looking at the equation, I should be able to kind of figure that out. But even at that, you got to be careful because it could go deeper, okay? So it is going to open up, but I need to figure out exactly how it's going to look. And so what I need to do now is I need to try to find the vertex. Where is the line of symmetry going to be at? The line of symmetry is going to be at the midpoint. So the midpoint between negative 2 and 4 is where? It would be at 1. So when x equals 1. So if the vertex or the midpoint is going to be where x equals 1, what would I have to do at this point to find the value of y? I know it's going to be there. I need to plug 1 into this equation. So next to it, I need to go y equals 1 squared minus 2 times 1 minus 8, okay? 1 squared is 1, 2 times 1 is 2 minus 8. 1 minus 2 minus 8 would be negative 9. So that tells me that my vertex then is at point 1, negative 9. Did you see that? So I come down here, roughly around there, and I say 1, negative 9. And then I draw my line. Wow, that wasn't that great, but you get the point. And there is my vertex, or there's my graph. Okay? All right. By the way, just going back really quickly again, just a quick glance. If I go back up to this equation right here, what is it? Y-intercept. The y-intercept is when x equals 0. So if this is 0 and this is 0, y-intercept would be at, it's negative 8. 0, negative 8. And does that make sense that you go here, 0, negative 8, it goes down a little lower to a point 1, negative 9, and then back up. There you go. So which was easier, using the vertex or using the y-intercept to draw the parabola? I don't know. That's kind of your call. Did you like the vertex? I guess the y-intercept kind of already, if you've got it in the standard form, it's already there for you. So you already have it and should be pretty easy to find. But if you wanted to get more exact, you could do the vertex and solve it that way. All right. Whew. So here's a summary of the zero product property. I'm just going to, if you want to read it, you can pause it and you can just look it over, but it basically explains what we just talked about, okay? All right, I know that was a lot, but again, everyone, this is not like Monday. This is a Tuesday. This is supposed to be a full school day. So this was longer, okay? But hopefully it's not complex. There's just a lot of stuff to it, okay? If you've got questions, feel free to email me. I will be checking my email throughout the school day on Tuesday. So just let me know and I'll try to get back to you as quickly as I can, okay? All right, otherwise, have a great day. The homework, please make sure you do the homework. And again, the homework for today is 69 through 75. Got it? 69 through 75. I will hopefully see you tomorrow. All right?